Lesson 3.5, Rationalizing the Denominator of a Fraction. The objective of this lesson is you must be able to apply rationalizing the denominator technique to different formats of surd problems, single term, multiple terms in the expression. So you're going to have to be able to recognize what the appropriate mathematical procedure is going to be to rationalize a denominator. So there'll be a couple of different methods we learn. The fun fact for the day, are green and black olives the same? So what is rationalizing the denominator? Well, first off, what is a rational number? A rational number is a number that can be written as a fraction. Okay, so a number that can be written as a fraction. And I'm going to add to this. This is your standard definition. If you were to Google what's a rational number, you're going to get this. Okay? And if you notice, ratio is in the word right here, ratio. And a fraction is a ratio, 2/3. Now, a rational number, before we get into irrational, a rational number terminates like or repeats. And I was going to say like 2/3, but 2/3 repeats. Okay, so if you were to punch 2/3 into your calculator, you would get 0.6 repeating. Okay, if you were to punch in 3/2, just flipping it around, you would get 1.5, and it terminated. Okay, but if you were to punch in the square root of 2 into your calculator, you're going to get a decimal that goes on forever that never repeats. So while they say in Google a number that can be written as a fraction, let's add to it that that fraction can terminate or repeat. Okay? So rationalizing the denominator is a math method that eliminates the irrational number in the denominator. So an irrational number never terminates. This is an irrational number. Never terminates, never repeats. Famous one that we use almost all the time now is going to be pi. But surds are irrational. If it is not a perfect square, square root of 3, square root of 11, square root of 17, square root of 213, okay? These are all surds. Surds are irrational, all right? Basically, what we're going to say is we're not allowed to have an irrational number or a surd in the denominator. So the method here is we're going to rationalize it. We're going to take it away and put a rational number in its place. Okay? So the point of rationalizing a denominator is to make it easier to understand what the quantity really is by removing the radical from the denominator. So that's what we're going to do. We're not going to have any radicals in the denominator. In this lesson, we're going to learn how to remove it from the denominator. So that's the goal of this lesson. So here we have a problem. Okay? We have a radical in the denominator. We're not allowed to have this. So we're going to get rid of it. Okay? To do this, if you remember our rule, the square root of 3 times the square root of 3 is equal to 3. We're going to use this rule to get rid of this. Remember, we can do whatever we want to an equation as long as we're multiplying it by a form of 1. We do it in the case of a big expression or equation as long as we do it to both sides of the equal sign. In this case, we're going to multiply this by the form of 1, square root of 3 over the square root of 3. This is 1. When I do this, I have 2 times the square root of 3. Square root of 3 times the square root of 3 just becomes 3. I have gotten rid of the radical in the denominator. This is a process, rationalizing the denominator. This is my final answer. Now I want you to go ahead, I want you to try this one on your own. See if you can use the same process and do this problem. Pause the video, give it a try. All right, so to do this, Basically, you multiply it by the same radical or the same surd that is in the denominator, square root of 2 over the square root of 2. When you multiply this, you get 5 square root of 2 over 2. Final answer. Now we have 2. We have square root of 2 and square root of 32. All I'm really worried about in this case is that square root of 32. So I'm going to multiply the numerator and the denominator by my form of 1. Okay. Now, notice what I did. I haven't done any simplifying. I'm going to simplify it after I rationalize it in this case. So watch what happens. So I have square root of 32, square root of 32. That is going to give me 32 on the denominator. That's what I need. But here I have 2 times 32. So this is going to become the square root of 64, right? We multiply the 2 times 32, we get 64. Well, square root of 64 is 8. So I'm going to simplify this down to 8 over 32. Now I have to look at my overall equation. It's 8 over 32. I divide everything by 8 to simplify. I'm going to get 1 over 4. Final answer. This one's a little bit different. You just have to distribute. You're still going to multiply by the square root of 2 over the square root of 2. So my form of 1 is set by the denominator, not by the numerator, but by the denominator. So I go ahead and I multiply. I'm going to distribute. 5 times the square root of 2 is 5 square root of 2. Square root of 2 times the square root of 2 is the square root of 4 or 2. You can write it, go ahead and evaluate it if you want. Here, and I get 2. Okay? So I have 5 square root of 2. Oops, that's a plus, sorry. Not. Plus 4 plus 2. Erase that here. So plus 2. So 5 square root of 2 plus 2 over 2. Now this says simplify when possible. I can't simplify this. I can't divide 5 by 2. And we're going to go over a couple to give you a simplifying problem. Next problem. So let's learn about conjugate surds. Do you remember the difference of squares? We did it last lesson in 3-4. Okay. Here's a difference of squares problem from algebra that gives you an idea. Okay. If we were to FOIL this, all right, so we do x plus 5 times x plus 5. You're going to get x squared. Let me write it down here. So we get x squared, then minus 5x. So I did the first one, I'll do the last one. Then I do plus 5x, and then minus 25. Okay. The whole key on a difference of squares is if you look here, I have negative 5x plus 5x. These cancel themselves out. This becomes 0. So I'm left with x squared minus 25. Now when we get into factoring and stuff, you're going to have to recognize this format of x squared minus 25. But the key to this lesson right now, all I want you to understand is when we do this, these middle terms cross out. Why are we going to do that? So we're going to use this idea to create a conjugate surd to eliminate the surd part and create a term that only has, that should say rational numbers. Not radical numbers. All right, so it creates a term that only has rational numbers. So let's go ahead and do it. So a conjugate surd. So I'm going to give you the square root of 3 minus 1. Okay? A conjugate surd of this is an expression. It's going to be the same terms, but we're going to change from a minus to a plus. Because by having one as a minus and one as a plus, when we do the FOIL method, the middle terms are going to be opposite of each other. Okay? So, from your book, here's the statement. The product of conjugate surds a plus b square root of c times a minus b square root of c is a rational number. So this is the definition. So if I have 1 plus and 1 minus, same terms, square root of 3 and 1, just one operation is minus, one operation is plus. When I FOIL these, I'm going to get square root of 3 times square root of 3, which is 3. Right? Square root of 3 times square root of 3. Then I'm going to do square root of 3 times 1, which is plus square root of 3. I'm going to do negative 1 times square root of 3, and there's my minus square root of 3. And then I'll do negative 1 times 1, which gives me positive 1. So I've done the FOIL. Now if you look, plus square root of 3 minus square root of 3, they cancel out, and I'm left with the rational number of 4. So by using the conjugate's the opposite sign, same terms, opposite sign. So I'll write that down in case you want to make a note of it. Same terms, but use the opposite sign. So if it's positive, use negative. If it's negative, use positive. Okay? So if you're given square root of 3, 2 square root of 3 minus 4, the conjugate would be 2 square root of 3 plus 4. All right? So it gives you an idea. Let's go ahead and do a couple of problems with this. All right, so use the conjugate surd to rationalize the denominator. So we have 5 over 2 plus square root of 5. So instead of now just multiplying it by square root of 5 over square root of 5, I can't do that. I have an expression down here. So I'm going to multiply this by the conjugate 2 minus the square root of 5. So this is the conjugate. But remember, I have to have it in a version of 1. So I have that. So now I'm going to go ahead and multiply. Yeah, you have to do FOIL. So my next step, don't want to do that yet. So we have 2 minus square root of 5. So I have 5 times 2. So I'm going to get 10. So I'm going to have 10 minus 5 square root of 5. Right? 5 times 2. 5 times negative square root of 5. Divided by 2 times 2 is 4. 2 times a negative square root of 5 minus 2 square root of 5. Square root of 5 times 2 is a positive 2 square root of 5. Square root of 5 times a negative square root of 5 is negative 5, right? This times this just gives me 5. Now I simplify it down. Negative, positive crosses out. I have 10 minus 5 square root of 5 divided by 4 minus 5 is negative 1. So you may see it in this format in your book, but most likely they go ahead and deal with the negative 1 and they make it negative 10 plus 5 square root of 5. So either answer would be correct. Go ahead and do this next one. Pause. See if you can figure it out. Okay, so if you did it, you should have gotten 2 plus square root of 3 over 2 plus square root of 3 is your conjugate. You did the multiplication. Your final answer should have been 4 plus 2 square root of 3. Now notice I had it over 1. The 1 doesn't, it just makes it a whole number, just the numerator. All right, so rationalize the denominator, simplify where possible. If you want, pause the video, give this one a shot on your own, see how you do. I'm going to go ahead and walk through it. So I have to look, I have this down here. I'm like, okay, so my conjugate should be the square root of 7, square root of 2, but it should be minus square root of 7 minus the square root of 2. So I go ahead and I go through the motions. Square root of 7 times square root of 7, well that's just 7. Square root of 7 times the negative square root of 2 is negative square root of 14. Then I have negative square root of 14 again, right? Negative 2 times negative square root of 2. over, or times negative 7, square root of 7. Then I have negative square root of 2 times negative square root of 2. That's going to give me a positive 2. Do the bottom. I get 7 again. Here, now I'm going to get a negative square root of 14. But on the second one, I get a positive square root of 14. And then I get a negative 2. So in this case, they're going to cancel out. So my next step, go ahead and combine like terms. Be very careful here, okay? These do not cancel out. Okay? So 7 plus 2 is 9. No problem there. But I have a negative square root of 14 and a negative square root of 14. That means I have 2 minus 2 square root of 14. So keep that in mind. Now here, the 14's canceled out, so I have 7 minus 2, so it's over 5. Cannot simplify, so final answer. All right, so now this takes it and makes it a little more difficult. We have to take this and we have to write it as a single fraction, okay? Now, the key here is you can always multiply anything by 1, okay? You can always multiply something by 1. So we're going to break this apart. We're going to look at it as 2 different terms. There's my first one. I'm going to skip a little space. I still have my plus here. There's still that plus. But then I have this one over here. We'll write this one in a different color. All right, so now I can multiply by 1. I'm not changing anything. So I'm going to take each term and I'm going to multiply it by its conjugate. So the conjugate of this one is 1 minus the square root of 5. So 1 minus square root of 5, 1 minus square root of 5. So let's go ahead and do that. We have 4. So we have 4. Then we have minus 4 square root of 5, right? 4 times negative square root of 5. Then we have square root of 5 times 1, so that's plus square root of 5. Square root of 5 times a negative square root of 5 is a negative 5. Positive times negative, negative 5. So that's the first part. Then over here, 1 times 1 is 1. 1 times negative square root of 5 minus square root of 5 plus square root of 5 minus 5. All right, so I'm going to lose these in the denominator. Combining my like terms, I can combine my like terms. I get 4 square root of 5 and the positive square root of 5. So 4 minus 5 is negative 1. Negative 4 plus 1, there's a 1 here. Okay, remember there's a 1. So that's going to give me minus 3 square root of 5 over negative 4. Okay. Now I'm going to come over here and I'm going to do the same thing. We'll do it in a different color. Let's pick green because it's very opposite of what we've got. We're going to multiply by 1 minus square root of 5. 1 minus square root of 5. Nope. What did I do wrong? I said minus, but I should have plus, right? Because that's the conjugate. Mistake on my part. So remember, be careful here. So it's a minus here. This should be plus. Let's go ahead and multiply. 4 times 1 is 4. Plus 4 square root of 5. Negative 5 times 1, negative square root of 5. Negative square root of 5, positive square root of 5 is negative 5. Okay. Then I do the denominator. I'm going to get 1 plus square root of 5, 1 times square root of 5, minus square root of 5, minus 5. Okay. When I combine my like terms, 4 minus 5 is negative 1. And then I still get now in this case I get positive 3 square root of 5. Right? Plus 4 minus 1 divided by 1. These will cancel, right? They're opposite. Plus square root of 5 minus square root of 5 is 0. 1 minus 5 is negative 4. Now these are still adding. Okay? One thing I want you to notice. You have a common denominator with that negative 4. Common denominator. Apparently I can't spell today. Okay. Okay, so we have a common denominator. That means I can combine these two statements. So we'll do this in blue. We've got to finish up the problem. We're going to bring it up here. Okay. So I have a -1 plus a -1. That gives me a -2. I have a -3 square root of 5 and a +3 square root of 5. Well, that actually cancels out. Okay, so these two cancel. And the denominator stays the same. So the final answer is actually -1 over -2, but a negative divided by negative is a positive, so my final answer is 1/2. Okay. So again, I'm adding these two down here, I'm adding them up because I have a common denominator. All right, so when I do that, these canceled out, right? -3 square root of 5 plus 3 square root of 5, 0. -1 and -1 made -2. The denominators, remember, we don't add those together, they stay the same. All right, now just remember, a negative divided by negative is a positive. All right, fun fact, are green and black olives the same? The color of the olive corresponds to the ripeness of the fruit when picked. That's it. So green olives are picked before ripening, and black olives are picked while they're ripe. So that's why you have kind of that sour, I don't know how you would explain it, sour taste with the green olives. So they have a different taste to them. Okay. Just a fun fact. So what should you know after completing this? The key here is to know which format of conjugate surd to use. Remember, square root of 5 times square root of 5 is 5, square root of 25. Okay. Do you see the pattern? Make sure you understand the pattern there. Okay. Multiplying a term by its conjugate surd results in a rational number. Okay. No surds or radicals are permitted in the denominator. And your paper will not receive full marks if you do not rationalize. That's kind of the key here. You got to rationalize the denominator. Make sure you write out each step. Really, I know some of you don't like writing it out, but if you make a mistake, it helps you find it or helps me find it if I'm trying to help you out on a problem. We're your friend helping you out. No credit if you don't show your work. You have to show your working. Okay? Thank you for participating.